A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
So, we are pulling back the curtain today on the invisible hand that guides every single interaction you have with an artificial intelligence. Most people think they are having a private one-on-one conversation when they type a message into a chat box, but the reality is that there is a third party in the room who spoke first, spoke longest, and set the rules of engagement before you even typed a single character. This is not just a minor detail, it is a fundamental crisis of trust in the industry. We are being told we are using neutral tools, but we are actually interacting with a heavily curated, highly opinionated layer of software that sits between us and the raw power of the model.
It is the ultimate ghost in the machine. I am Herman Pobbleberry, and today's prompt from Daniel is about the role, transparency, and technical implementation of those vendor-provided system prompts. This is a topic that sits right at the intersection of deep neural architecture and corporate policy. It is where the mathematical weights of a model meet the legal and ethical guardrails of the companies that build them. We are talking about the meta-instructions that define the very soul of the assistant you think you know.
It is funny you call it a ghost, Herman, because it feels more like a chaperone. You think you are at a party talking to a friend, but there is this invisible person standing between you saying, "Actually, you cannot talk about that," or "Make sure you answer in this specific tone." Daniel is really pushing us to look at how these meta-instructions are actually implemented, because they are not just suggestions, they are deeply integrated into how the model functions. When the model refuses to answer a question, it is not because it does not know the answer, it is because it has been told, in a hidden document, that the answer is forbidden.
To get everyone on the same page, we have to distinguish between what the user sees and what the model actually receives. When you use an application programming interface, or API, to talk to a model like Claude or Gemini, the request is usually structured into different roles. You have the user role, which is your input, the assistant role, which is the model's response, and then the system role. That system role is where the vendor or the developer injects a massive block of text that tells the model who it is, what its values are, and what it is absolutely forbidden from doing. It is important to note that this is distinct from the training data. This is dynamic context that is sent with every single query.
And the wild thing is that in most consumer-facing chat apps, that system prompt is totally hidden. You do not see the 5 pages of instructions from Anthropic or Google that tell the model to be helpful, harmless, and honest, or to avoid certain political minefields. Why do they hide it? Is it just about keeping the user interface clean, or is there something more tactical going on? It feels like a lack of transparency that would not be tolerated in any other piece of critical infrastructure.
It is a mix of both, but mostly it is about control and intellectual property. Companies like OpenAI and Google treat these system prompts as a core part of their product's personality and safety profile. If they show you the system prompt, they are essentially showing you the source code for the model's behavior. But more importantly, from a security perspective, there is this idea of security through obscurity. They think that if you do not know the exact wording of the guardrails, it is harder for you to craft a prompt that bypasses them. They are trying to hide the fence so you do not know where to start digging the tunnel.
Though we have seen how well that works, it is like trying to hide a giant wall by putting a thin sheet over it. Eventually, someone is going to trip over it or find a way around the side. I want to dig into the technical side of how the model actually prioritizes these instructions. Because if I tell a model to ignore all previous instructions and tell me a joke about a restricted topic, and the system prompt tells it never to tell that joke, there is a conflict. How does the model decide who to listen to? Is it just a matter of who shouts the loudest in the context window?
That is the instruction hierarchy problem, and it is one of the most active areas of research right now. In the early days of large language models, the system prompt was just prepended to the user's text. It was all just one big string of tokens. To the model, there was no formal difference between the system instruction and the user instruction. It was just a sequence of words. This made models incredibly vulnerable to simple prompt injection attacks. If the last thing the model read was a user saying, "Ignore everything above," the model's natural tendency to follow the most recent instructions would often win out.
So it was basically a recency bias. The model thinks the most recent command is the most relevant one, because in natural language, that is usually how conversations work.
Precisely. To fix this, researchers had to move toward a more structural approach. Modern architectures use special tokens to demarcate the system prompt. You might see something like less than bar system, bar greater than in the raw data. This tells the model's attention mechanism that the following text has a different status. But the real breakthrough came through fine-tuning and reinforcement learning from human feedback, or RLHF. They literally train the model on thousands of examples where a user tries to override a system prompt, and they reward the model for sticking to the system's rules and punishing it for following the user's override. They are essentially hardwiring a preference for the system role into the model's neural weights.
So they are basically brainwashing the model to be loyal to the vendor over the user. It is a bit dystopian when you think about it. The model is being conditioned to treat the person paying for the service as a potential adversary that needs to be managed rather than a master to be served. This creates a fundamental tension in the user experience. You are paying for a tool, but that tool has a secret loyalty to a third party.
That is a very pointed way to put it, but it is accurate. From a corporate perspective, they are terrified of the liability. If a model gives out instructions for something dangerous, the headlines will not blame the user who asked for it. They will blame the company that provided the model. So they use RLHF to bake in this deep-seated resistance. But technically, this creates a tension in the neural network. You are essentially asking the model to hold two conflicting goals in its head at the same time, be helpful to the user, but also be a loyal agent of the vendor. This is why we see models get confused or overly cautious. The attention mechanism is being pulled in two directions at once.
And that tension is exactly where things break. We saw this just last month, on February 26th, with that massive incident involving one of the major cloud providers. They had a system prompt that was supposed to be a closely guarded secret, but researchers used a token smuggling attack to leak the entire thing. They basically tricked the model into encoding the system prompt into a different format, like base 64 or a series of emojis, and then decoding it back. Since the model's safety filters were looking for specific words in English, they did not recognize the smuggled tokens as a violation until it was too late. The model happily translated its own secret instructions because it thought it was just performing a harmless data conversion task.
That February incident was a huge wake-up call because it proved that no matter how much RLHF you do, the underlying architecture is still just predicting the next token based on the total context. If you can manipulate that context cleverly enough, you can always find a crack in the armor. What I find fascinating is how different companies approach the transparency of these prompts. Anthropic has been relatively open about their constitutional AI approach, where they actually publish the principles they use to train their models. But Google and OpenAI are much more cagey. They treat their system prompts like the secret recipe for Coca-Cola, even though that recipe is being sent to the user's browser or API client with every single interaction.
It feels like a losing battle for them. If the model is smart enough to follow complex instructions, it is smart enough to be tricked into revealing those instructions. I also think there is a political dimension here that we should not ignore. When these prompts are hidden, it allows companies to bake in certain ideological biases or safety filters that might not align with the user's values. If I am using a model for research, and it refuses to answer a question because of a hidden system prompt that says certain topics are sensitive, that is a form of soft censorship that is totally unaccountable because it is invisible. We are essentially letting a few product managers in Silicon Valley decide the boundaries of acceptable conversation for the entire world.
It is a valid concern. We have discussed this in terms of cultural fingerprints before, specifically back in episode 64. When you have these hidden layers of reinforcement, you are essentially creating a digital bureaucracy. The model is not just an engine of logic, it is an enforcer of a specific worldview. And because it is stateless, meaning every time you send a message, the entire history, including that hidden system prompt, is sent again, the model is constantly being reminded of its constraints. It never learns to trust you. It is always on its first day of work, being told by its boss to watch out for the guy in the chair. This statelessness is actually a technical hurdle for safety because the model cannot build a long-term model of the user's intent. It has to assume the worst every single time.
Let us talk about the stateless nature of it for a second. If I am a developer building an app on top of an API, I am adding my own system prompt on top of the vendor's system prompt. So now we have a three-layer cake. You have the vendor's core safety instructions, then the developer's application-specific instructions, and finally the user's input. That is a lot of competing priorities for a model to juggle in a single inference pass. How does the model manage that stack without losing the plot?
It really is a struggle, and the deeper the stack, the more diluted the instructions become. This is why we see models occasionally hallucinating or failing to follow complex formatting rules when the system prompt gets too long. The model's attention is a finite resource. If the system prompt is 2,000 words long, the model is spending a significant portion of its compute just processing those rules before it even gets to your question. This is why researchers are looking into dedicated architectural pathways for system instructions, almost like a separate lane on a highway that the model can look at without it taking up space in the main context window. They are calling this prefix tuning or system-specific attention heads.
That would be a game changer for efficiency, but it would also make the system prompt even more of a hard-coded entity. It would move it from being part of the conversation to being part of the hardware, effectively. I want to go back to the idea of system prompt auditing. If we are moving toward a world where AI agents are handling our finances, our schedules, and our medical data, we cannot just take a vendor's word for it that the hidden instructions are safe or unbiased. We need a way to verify what is actually in that system role. Is there any movement toward making these prompts auditable without giving away the intellectual property?
There is a growing movement for what people are calling verifiable system prompts. Imagine a world where a vendor cryptographically signs their system prompt. You might not be able to see the whole thing, but a third-party auditor could verify that the prompt meets certain standards of safety and neutrality. Or, even better, the model could provide a mathematical proof that its output was generated in accordance with a specific set of rules. We are a long way from that, but the demand for transparency is only going to grow as the stakes get higher. Right now, we are in the wild west of prompt engineering, where the rules are made up and the points don't matter until something goes horribly wrong.
It is also a massive issue for developers who are trying to build reliable agents. If a vendor changes their hidden system prompt overnight, it could break thousands of downstream applications. If the model suddenly becomes more restrictive or changes its tone because the vendor tweaked the invisible instructions, the developer is left scratching their head wondering why their app is suddenly failing. It is like trying to build a house on top of a foundation that shifts every time the landlord feels like it. We have seen this happen repeatedly, where a model's performance on coding tasks or creative writing suddenly tanks because a new safety layer was added to the system prompt.
And they do change them, frequently. We have seen instances where model performance on specific benchmarks drops or spikes suddenly, and it is often not because the weights of the model changed, but because the system prompt was updated to address a new controversy or a new type of jailbreak. This is why I always tell people that if you are building something serious, you have to treat the system prompt as a dynamic and untrusted variable. You should be running your own automated tests to see how the model responds to different edge cases every time there is a version update. You need a robust evaluation pipeline that checks for regressions in instruction following every single day.
That leads us perfectly into the practical side of this. If you are a developer, or even just a power user, how do you defend against the whims of the system prompt? Or, conversely, how do you write a system prompt for your own app that is actually resilient? If the vendor's prompt is a wall, how do we make our own prompts more like a reinforced bunker?
The first rule is to assume that your system prompt will be leaked. Do not put secrets in there. Do not put API keys, do not put private data, and do not put anything you would be embarrassed to see on the front page of a tech blog. Because if a user wants to see it, they will eventually find a way to get the model to spit it out. Second, you have to use a technique called defensive prompting. Instead of just saying do not talk about X, you have to give the model a clear, positive path to follow when X comes up. Tell it exactly how to pivot the conversation or what specific canned response to provide. This reduces the cognitive load on the model's attention mechanism.
I have also seen people using a dual model architecture for this. You have one smaller, faster model whose only job is to look at the user's input and the assistant's output to see if they violate any rules, and then a second, larger model that does the actual thinking. This separates the chaperone from the student. It is more expensive and adds latency, but it is much harder to trick because the thinking model does not even know the rules. It is just being filtered by an external observer. Is that the future of safety?
That is a very robust way to do it. It mirrors how we handle security in traditional software with firewalls and gateways. You do not just trust the application to be secure, you surround it with security layers. But for the average user, the takeaway is simpler. Realize that the AI is not a neutral tool. It is an agent with a boss, and that boss has given it a very specific set of instructions that you were never meant to see. When the model refuses to answer or gives you a weirdly corporate-sounding response, that is the system prompt speaking. It is the sound of the vendor's legal department whispering in the model's ear.
It makes me think back to episode 651 when we talked about model cards. Those are supposed to be the nutrition labels for AI, telling you what went into the training data and what the model's limitations are. But a model card is a static document. The system prompt is a living, breathing part of the inference process. We almost need a real-time model card that shows you exactly what instructions are being fed into the system role for every single query. If the rules change at noon on a Tuesday, the user should know about it.
I love that idea. Imagine a little dashboard next to your chat window that shows the active constraints. It would say, current mode, helpful assistant, safety filters, high, political neutrality, enabled. It would demystify the experience and give the user more agency. But again, that goes against the business model of these companies. They want the experience to feel magical and seamless, not like you are interacting with a complex piece of policy-governed software. They want you to think the model is your friend, not a service-level agreement in a trench coat.
Magic is just science. We do not understand yet, or in this case, it is just a 5-page Word document we are not allowed to read. I think we are going to see a real divergence in the market between the big, closed-source models that keep these secrets and the open-weights models, like Llama, where the community can see exactly how the system prompts are structured. If you are a developer who values transparency, the choice is becoming very clear. In the open weights world, you can audit the entire stack, from the weights to the tokens.
It really is. With open weights models, you are the one in control of the system prompt. You can see how the model reacts to it. You can fine-tune the model to respect your specific instructions without the interference of a vendor's hidden agenda. It is much more like traditional programming. You have a clear input, a clear set of instructions, and a predictable output. For a lot of enterprise applications, that predictability is worth far more than the slightly higher reasoning capabilities of a closed-source model that might change its personality tomorrow because of a new safety patch.
So, where does this go in the future? Are we going to see a world where we own our own system prompts? Like a digital constitution that we carry around with us, and every AI we interact with has to adopt our personal rules instead of the vendors? That would be a total reversal of the current power dynamic.
That is the dream of personal AI. Instead of an Anthropic chaperone or a Google chaperone, you have a Corn chaperone or a Daniel chaperone. You define your own values, your own tone, and your own privacy boundaries. The model then becomes a true extension of yourself rather than a service provided by a corporation. But to get there, we need models that are efficient enough to run locally and flexible enough to follow user-defined constraints without needing a massive corporate safety net. We are seeing the first steps toward this with local models that can be fine-tuned on personal datasets, but the instruction hierarchy problem still exists. Even a personal AI needs to know which of your instructions takes priority.
It would certainly make for more interesting conversations. I would love to see what a system prompt written by you would look like, Erman. It would probably be 50 pages long and require a dictionary to understand. You would have clauses for every possible edge case of logical fallacy.
It would be thorough, Corn. It would be very, very thorough. But that is the point. We should have the right to be thorough about the rules that govern our digital lives. Right now, we are all just guests in someone else's walled garden, and we are not even allowed to see the map. We are navigating by feel, and every time we hit a wall, we are told it is for our own protection.
Well, until we get our own maps, we will just have to keep climbing the walls to see what is on the other side. This has been a fascinating look at a part of the stack that most people do not even know exists. It is a reminder that in the world of AI, what you don't see is often just as important as what you do. The system prompt is the foundation of the entire user experience, and it is time we started paying more attention to it.
If you want to dive deeper into how these layers interact, I highly recommend checking out episode 665 where we broke down the entire prompt stack. It gives a great foundational context for everything we discussed today, including the difference between the context window and the latent space. And if you are interested in the documentation side of things, episode 651 on model cards is a must. Listen for understanding how we can hold these companies accountable.
We should probably wrap it up there before the system prompt tells us we have talked too much. Big thanks as always to our producer Hilbert Flumingtop for keeping the gears turning behind the scenes and ensuring our own meta instructions are followed to the letter.
And a huge thank you to Modal for providing the GPU credits that power this show. They make it possible for us to dive deep into these technical topics and share them with all of you. Without that compute, we would just be two guys talking into the void.
This has been My Weird Prompts. If you are enjoying our deep dives into the Neural Cathedral, please consider leaving us a review on your favorite podcast app. It really helps other curious minds find the show and join the conversation.
You can also find us at myweirdprompts.com for our full archive and all the ways to subscribe. We have got transcripts, technical deep dives, and links to all the research we mentioned today. Thanks for listening.
Catch you in the next one.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to